Yes, hi guys. So I was doing question number 6. Now let me continue from this. Now question 6 I'm doing. Okay, in this question what I'm doing here, find the volume enclosed by the coordinate planes. Coordinate planes are x equal to 0, y equal to 0, x equal to 0 here, y equal to 0, z equal to 0. Okay, in the plane and the portion of the plane and the portion of this plane, okay, Lx plus My plus Nz equal to 1, lying in the first quadrant. Now in the first quadrant it is lying. Okay, so some portion of this, let me take this is quadrant of this portion. In this case, what we are doing, z equal to 0 in the plane, suppose I have taken, okay, from this plane to this. Okay, we have to find out the volume of this plane. We have z, volume of this quadrant of this plane, part of this plane, and the coordinate axis x0, y0, x0 here, this is x0 here, z0 here, y0. Okay, so in the plane test, so volume of the given volume of the solid given, solid here, and the volume of the enclosed, okay, volume enclosed by the coordinate, and the volume of the solid maybe, and the volume of the solid enclosed by the coordinate plane. Okay, the volume of the given plane or required plane, given plane in the quadrant, in the first quadrant, is given by V is equal to, let me take triple integral here. Okay, it is z into, or let me take double integral, because this is y lying in the first quadrant only. So this is two-dimensional geometry here. This is only first quadrant, it means only one plane. Let me take this one, x by plane here, it will be the first quadrant here. So I'm not taking this one, so here it is not, it is here, in this plane it is here. Okay, so if I take the same type of figure like here, as I was taking at that time, but this is not this kind of figure, but volume of this figure will be z into dx/d5. Okay, so what is given here? Here volume is surface area. We take surface area here. What is the final value of this? Here limits are, right here limits. From this one, x equal to, if I put 0, x equal to 0 to, or x equal to 0, if I put limits of, right here, limits of x equal to 0 here, if I put x 0, for x 0, x will be equal to 0 to this one, x equal to 1 from 0 to 1 from L, and y will be equal to 0 to, this is the only first quadrant. I mean this one, positive quadrant. If I take the first quadrant in x by plane only, z equal to 0 here, y equal to 0 to, y equal to this value. So we find out y from here, it will be 1 minus Lx upon m. This is the value of y from here. M by equal to 1 minus Lx, or m by, we have to divide by m. This is y equal to 0 to this limit, and z is given by this equation. Z from this one, we have calculated z, and z equal to 1 minus Lx from minus m by upon n. This is the value of z. If I substitute z in this case, what are the limits for x? X is 0 to 1 upon L here. Y is 0 to this 1 minus L into x upon n into z. Okay, and z value is this much, 1 minus Lx minus my upon n, okay, into dx dy, into dx and dy. Okay, so this is the value of this figure given to us. Now let me solve it. First, integrating this, let me take 1 upon n outside. This is 1 upon n here. This is only one quadrant. It says only in the first quadrant. It may be the first quadrant here, xy plane. If I take xy plane there, z can be here then x by z. In that way also we can take, but here I am taking this xz plane here, but z equal to 0 and this plane is here. So one point n, this is 0 to 1 point l. Okay, and this is 0 to 1 minus lx upon n. This n I have taken. Let me integrate this with respect to y. So it is to be integrated with respect to y. Dy, let me write here. First I have to integrate it with respect to y. What is the integration? Let me write this integration here. So volume of this plane required plane here 0 to 1 point L. The equation of the plane given is 0 to 1 point L, and this will be integration of this is with respect to y. First y here minus L into x into y. So let me take 1 minus Lx into y of this equation minus sin n into y square upon 2. Now upon this limits we have to substitute. This is 0 to 1 minus Lx upon n. This is limits for y 1 minus Lx upon n here. Okay. This is the limit. Now let me solve it here. Further, let me solve this. Putting the value of the limits here. What are the limits? Let me put this here. 1 from n, 0 to 1 from n. Substituting the limit here, 1 minus Lx upon n. So in place of y, we have to substitute this limit. Upper limit at lower limit 0, y0 is 0 to. At lower limit, both the terms will be 0, but on the upper limit, which is 1 minus Lx upon n, in place of y, we have to substitute. This is 1 minus Lx already there, and this 1 minus Lx has again come upon n. It's minus sign. This y here now, this is m upon 2. Y is 1 minus Lx upon n whole square. So this is y square here. Only at 0, everything is 0, this is ds here. And sorry, this is ds. Now integration with respect to x. Finally we have to do, but before that let me solve 0 to 1 upon l. What is here? This is 1 minus Lx. Let me put here bigger bracket. 1 minus Lx whole square upon n. Minus sign from this 1 m will be there. This is n square here. This is 1 minus Lx whole square upon twice n. Why? So 1 m will be cancelled out. This is in the denominator we will have n square. And this m and this m square, 1 m is cancelled out. Okay, so that is value into ds. What about this? This is half of this m. If I take m common, let me take m into m common. 1 upon m into 1 common. This is 0 to 1 upon l. Okay. Into this value. This is only half. This is half of this value. This is positive. Okay, this is 1 suppose. I'm taking this. This will be 1 minus Lx whole square minus 1 upon 2. This will be 1 minus Lx whole square. That means this is only half of this value is left over positive. This is minus half. This is plus 1. So let me write here. So finally, the volume V is equal to 1 upon n. Integration of this, but you first write down 0 to 1 upon l. Left over value is 1 upon 2 and 1 minus Lx whole square. Okay, so this value is left over only. Now let me further integrate it into dx here. With respect to x, we have to integrate it. For the integration, let me write here. Okay, so integration. This is 1 from twice n into n, 2 I have taken outside, and now this is 0 to 1 from n. Of integration of this, before that let me put here putting 1 minus Lx equal to t, putting another value, differentiating it with respect to t, we get here, it will be minus L into dx equal to dt, or dx equal to minus dt upon L. What are the limits here? Can we find the limits? At x equal to 1 upon L, at x equal to 1 upon L, t equal to how much? 1 minus L into 1 upon L, that means 1 minus 0, t equal to 0. Upper limit 0 in this case, and at x equal to 0, here if I substitute here 0, it is 1, and at x equal to 0, t equal to 1. Why? Because this 1 minus Lx, x is 0, t equal to 1. Limits are, let me write here, this is 1 pound twice this here. Okay, I will write it here. So this is minus t plus t square into minus dt upon L, and limits are here. What are the limits here now? Now limits are 1 to 0. This minus sign will make it positive. Let me take that. It will give us 1 upon twice m into n. Now this is 1 to 0, but this minus sign will make it positive. Now L is also, L we have to take outside. It will be L into m into n. Okay, and this is t square of 0 to 1 because it is minus sign. Okay, into dt is value there. In case of t we will do, but before that let me write here the formula. Since if limits are a to 0, okay, and this is minus sign, let me take fx minus fx into dx, and it will be positive sign 0 to a. This because it is minus sign, this limits are okay, exchange, limits are interchange. I mean, this lower limit will come in upper limit, minus sign will become positive. So this is fx into dx positive. Similarly here, but because it is minus sign, they will reverse the limits. This is 0 to 1 now. So finally, what is the then? This is 1 point twice L and n. Okay, and this is t cube upon 3 integration of t square 0 to 1 limits. It is 1.3 only. It will give us 1.6 L and n. This is the answer here. Final answer is this. This is the answer. 1.6 L and n. Okay, so this value is here. Finally, question we have done. Question number 6 is 1.6 L and n. Question 6 solved. Now let me take 7th question. Question number 7. Let me check. We are finding out volume by multiplying. This is check. Okay. Now let me take question number here. Now let me take 7th question. So what is question number 7 say? Okay. This is the 7th question here. Obtain the volume bounded by the surface. Okay, which is surface z equal to c into 1 minus x upon a into 1 minus y upon b, and the quadrant of the elliptic cylinder x square upon a square is y square upon z square equal to 1. This yes, elliptic cylinder. Elliptic cylinder. Here z is the axis of this cylinder. Elliptic cylinder is having this equation okay, but z axis is the equation of axis of the cylinder. Okay, this is elliptic cylinder. That we will do here. Z is given like this. We have to write here what are the limits for this. Now let me change this into polar coordinates. So what is the question here? The 7th question. they are given here. What is given to us? Z equal to C into 1 minus, this is x upon a, okay, this is x upon a into 1 minus y upon b. This is the value of the surface here and the quadrant of the elliptic cylinder. What is elliptic cylinder? X square upon a square, y square upon b square is equal to 1. This is elliptic cylinder. Now this elliptic cylinder, elliptic cylinder, not elliptic but it's elliptic or elliptical. This is elliptical. Elliptic cylinder. I'm sorry. This is elliptic cylinder, not elliptic, but elliptic cylinder. Right from ellipse, made from elliptical form. So okay, it is clear. Now the axis of this plane, this cylinder, the axis of this cylinder is z axis. Because the axis of this cylinder is z axis. Below, this is symmetric to the z axis here. Z axis is the equation of this, right? Now let me sorry. Now let me solve it here. What is the volume of this? And to find out in one of the quadrants here, it says in the quadrant of the elliptic cylinder bounded by this plane and this elliptic cylinder. Solution let me find out. Now if I substitute polar coordinates, let me change it into polar coordinates. Changing it into polar coordinates for elliptic or elliptic polar coordinates. Elliptical polar coordinates. Elliptical polar coordinates, what are them? X equal to r cos theta, y equal to b r sin theta. This is the elliptic cylinder. Now if I find out what is dx dy and dx dy will be equal to this a into b. Now here Jacobian will be abr into d theta dy or r d theta dy, but abr is Jacobian value. Why Jacobian value? Because del x you can calculate del x by del r theta is equal to ab, in this case ab into r. Therefore abr into d theta dy. In case of d by dx or dx d by dx here, we will write this dx dy or d by dx is equal to this value. We will write here Jacobian is abr. Okay, now what about this equation then? Therefore z equal to here z equal to c 1 minus, in place of x if I substitute ar cos theta, that means r cos theta will be there. It will be r cos theta, because a cancelled out, into 1 minus it will be r sin theta. Therefore volume for the quadrant of one quadrant volume is given by, okay, this is in double integral because xy is given. Double integral z into dx dy, which is given. This is surface here or double integral of x. What is the limits for x here? Sorry, theta and r, but we have changed it to polar coordinates. Here r will be left right, but this is x square, that means r square equal to 1. R square equal to 1, in bracket r is equal to 1. Limits for r by r square. Here x is ar cos theta, a square r square cos square theta, a cancel out, r square cos square theta, this is r square sin square theta, r square common, cos square theta plus sin theta equal to 1, that means r square equal to 1 from this equation. This is And take second equation, first equation. From second equation we have got this. Okay. Now this is the first quadrant only. Therefore, theta will be 0 to pi by 2. Limits for theta 0 to pi by 2 and for r 0 to pi by 2. This is r, therefore limits are r equals 0 to 1. And theta, because it is in the first quadrant, is 0 to pi by 2. In the first quadrant, 0 to pi by 2 are the limits for theta. 0 to, let me write here, 0 to pi by 2. But first theta 0 to pi by 2 and r is 0 to 1. This z value is from this one. This is c into, that c before, c into 1 minus r cos theta into 1 minus r sin theta. Okay, and into this ABR. Now let me work this. This is value of z, which is this one. This value here, z equal to 5. Here, z is the c into 1 minus r cos theta into 1 minus r sin theta into this dy is this value ABR into dr d theta or d theta dr is problem. This is value of the volume here in terms of polar coordinates. Okay, now let me solve it. This will give us ABC. Okay, let me take ABC outside. 0 to pi by 2, 0 to 1 here. Now put this one. Okay, these are r limits, but before that let me multiply the r into this. Let me multiply these two. We first 1 minus r common here. What is it? R cos theta. It is cos theta plus sin theta. Okay, then multiplication of these two will be plus sin r square sin theta into cos theta. Okay, into this r dr, r into dr d theta. Already multiplied by r inside. It will be, what is here? Let me write here. The value of this will be volume we are finding out in the first quadrant. ABC 0 to pi by 2 theta limits, and the r limits are these, but before that we multiply by r inside, which will be r 1 into r means r minus r square sin theta plus cos theta. This one plus r square into sin theta cos theta after multiplication into this is dr into d theta. Now integrating it with respect to r first and then with respect to theta. So final answer will be there then. This is, let me write here. This is ABC 0 to pi by 2. Integration of this will be r square upon 2. This is r cube upon 3 into sin theta plus cos theta in brackets. Here r cube, where are got this point here? Something is mistaken. Here r square was already there, it was r cube here. And it was r cube already. For this r into r square here was, which is r4 upon 1. It will be r4 upon 4 into sin theta cos theta. Okay, now d theta. Limits we have substituted. Yes. No, I'm sorry, we have integrated it with respect to r here. Now limits are 0 to 1 in case of r. Okay, so this is ABC 0 to pi by 2. In case of r, we have substituted 1. This is 1.2 minus 1.3 sin theta plus cos theta. This is 1.4 here plus 1.4 sin theta into cos theta. Now d theta. And 0 it will be 0 because r0 if I replace, then all the 3 terms will be 0. Now it is to be integrated with respect to theta. So theta is there now. This will be, let me write ABC, integration of 1.2 into theta, because theta is not there, 1 integrated by theta, minus this is 1.3 sin theta integration to minus cos theta. This cos theta is sin theta, positive integration. Now here, suppose sin theta you can t, cos theta d theta is dt, that means t square upon 2, that is t, sorry, t we are taking sin square, it will be sin square theta upon 8, 2 into 4. This is the integration, limits now 0 to pi by 2. Okay, all the integration is done, complete integration. Now if I substitute the limits 0 to pi by 2, at pi by 2, it will be 0 because this is cos 0, cos pi by 2 is 0, sin pi by 2 is 1, it will be 1 here, 1 into this minus, let me write here, this is ABC, at pi by 2 this is pi by 4, so that theta is at pi by 2, 1.2 is there, pi by 4, it is minus plus here, so this is 0 for minus sign, it will be minus sign, sin pi by 2 is 1, it is 1.31, positive value, sorry, this negative value, when we substitute upper limit, plus 1.8 for sin pi by 2 is 1, so 1.8 only. Now at 0, this term is 0 first theta, but this cos theta 1, that is 0. The negative sign is there, triple negative. This negative sign, it will be negative, still negative. Minus 1.3 there. Okay, you add 0 to there. So let me check whether any mistake. Cos theta, sin theta by minus cos theta, okay. And this cos theta is sin theta, integration, positive. Okay, look at this now, this was minus sign here. The minus sign equals 1 minus, all that. This minus 1.3 minus 1.3, 2 by 3, this plus 1.8, 2 by 3 plus 1.8. Okay, only we have to solve them. These three values are to solve. Let me finally solve it. The answer will be, let me write here down. It is ABC pi by 4 minus 2/3 plus 1.8. If I solve these two, 24 is the LCM. Pi by 4 minus sign here. Budget percent. But if I put cos 0, it is 0, but it will be then positive, but it's minus sign. So if it is minus plus, but it will become negative. It is minus sign 1.3. In that case, but in first case, it was 0, but this minus sign and this minus sign, but this minus 1.3. Because any mistake, if this is there, then numerical value will be mistaken, but not to solve it. Minus 2 by 3, we have taken the LCM of this 2 by 3 and 8. Let me take 24 as the LCM. 3, 8 is 24, 8 plus 16. Let me take minus 16 here, plus 8, 3 at 24, this is 3. So 16 minus 3 minus 13 upon 2. This change is coming out. Minus 13 upon 2. It's negative value. This value is something different. Pi by 4 is okay, but this value will come here, pi by 4. It was 1.4, it was minus 1.3. From here this has come out. Okay, there was R2 upon 3. It was R4 upon 4. No problem. This is it. It was R here, here it is. Okay. Let me check, because R square integration by R2 upon 3, it was minus of course. Okay, that is it. we can't change. So this is the right answer. Answer is this. Pi by 4 minus 13.4. Maybe numerical value is listed now. This answer. Question number 7 is ABC into pi by 4 minus this. Okay. Question number 7 is done. So question number 7 is now complete. Now let me talk about 7th question. 8th question now. Question number 8, 9, 10, 10. 3 questions are there. Now in the question number 8 set, what is given to us says find the volume of the bounded by the ellipsoid. This ellipsoid here. The ellipsoid. So ellipsoid is given to us as twice x plus y plus z whole square plus sine is 3x minus y plus z whole square plus it is 4 times x plus 2y whole square equal to 16. Okay. This is the ellipsoid given to us. You have to find out the volume of this and the volume of this ellipsoid bounded by the ellipsoid this. Okay. Let me solve it. Now this ellipsoid, volume of ellipsoid or anything is triple integration. Let me take. This is the ellipsoid here. This is dx, dy, dz. No problem. This is the volume. We change this. Okay. So this is the ellipsoid we are given here. Okay. So this ellipsoid is there. Now, which question we are doing here? Okay, this is ellipsoid here. Think about that's good. Okay, find the volume bounded by the ellipsoid. Okay. Now, if I change this ellipsoid into a sphere, then this suppose I take one variable, another variable, third variable. Let me assume here. Let me take twice x plus y plus z equal to capital X. No problem. And the 3x minus 5 plus z equal to capital Y. Okay. And this is twice into x plus 2y equal to, let me take capital Z. Okay. This equation will convert this ellipsoid. Therefore, the given ellipsoid